Okay, well, sure. So let me start off by saying, definitely there is this misconception that Torah, God, and science have like a conflict between each other, that science somehow says God doesn't exist. And we think that's not, couldn't be further from the truth.
Hmm.
I think that science, in fact, shows that God does exist, not in mathematical proof or anything like that, but a convincing, compelling argument. And that's what our podcast, Physics to God, is essentially. We're trying to give over that argument. And normally we try, there's a certain way we give over the argument. We thought it would be fun today if we kind of did it in a completely different way. Because we once had this analogy between chess and physics. And we thought it would be interesting if we kind of try to give over how the idea of God and physics work together, but using chess as an analogy.
I love
Um,
it.
are you ready? Okay, fine. So we kind of prepared this. We haven't done this before. We wrote this up years ago, and we decided not to publish it. But so we just we'll look through it again today. We thought it'd be fun. Okay, so we're gonna try this. Ellie's gonna start with the chess part of the analogy, and then I'll try to convert it to physics. Then in the end, we're gonna come back to God.
Sounds good.
Oh, I'm game.
Okay. Okay, great. So I guess we're talking about, let's talk about the game of chess. Okay, actually, this is where this comes from. It comes from Richard Feynman, had the famous physicist Richard Feynman, one of the greatest physicists of the last generation. So he had a comparison of the game of chess to laws of physics, and he kind of trying to analogize what are we doing when we're studying physics. He thought of it. Imagine a person who's watching a game of chess and that doesn't know the rules of chess, and they were kind of observing many chess games and they're trying to figure out what the rules of the game are. And he thought that's kind of what physicists do. We look at the universe, or scientists, we look at the universe and we try to discover the laws which govern the universe. And that's like the process of a scientist is trying to uncover those laws. So with that analogy in mind, we thought we're going to try to compare the game of chess and the laws of chess to expanding on his analogy to the different components of the laws of physics. Okay, so let's start out with a game of chess. So you could correct me if I'm wrong. Again, we're not experts in chess, so we're probably gonna make some mistakes or whatever. But please feel free to correct us on
Heck,
anything. We'll
we'll
be,
have a
you know,
good, productive conversation.
yeah, exactly right. So okay, so basically the game of chess, you can consider it is we broke it down to three components. Okay, you have the board, you have the pieces and all how the pieces move and all that. And then there's the initial setup, how the game, how the pieces start out. Okay, sounds good.
Sounds
I'm
very
game.
good. Okay, fine. Okay, now in
Yeah.
physics, um, modern physics, you have three things. You can kind of split up the universe in three ways here. So first you have the particles themselves, the fundamental particles. They're like the basic constituents of the universe, like electrons and quarks. They're things that can't be broken up into anything else. That's why they're called fundamental, the building blocks of all matter. And those are governed, the way they work, the way they move, the way they move and interact is governed by quantum mechanics. Okay, that's kind of analogous to like the pieces in chess. There's different types of pieces that move in different ways and they interact with each other. That's one slice of the universe. The other is space-time. That's like the framework where all the particles interact with each other, what they exist in. It's like a background. We'll talk about special relativity for now. That's just like basically a fixed background of space-time where the different particles exist in and they move in space as time progresses. It's really one thing in physics, a little more complicated than chess maybe. And that's the equivalent to the chessboard. And the last thing would be the initial conditions of the universe at the Big Bang, the state which the universe started off. There's a lot of different ways the universe could have started off, even more than the number of ways you could start off on a chessboard. And the particular way that the universe started at the Big Bang is called the initial conditions of the universe. So those are the three things that correspond to three parts of chess.
So far, so good.
So far, so good.
Okay, good.
Yeah, I was
Okay.
thinking like, opening, middle game, end game, for
Yeah,
instance.
yeah. That's
Hey,
true.
there,
That's
there
true.
could be, many
Yeah.
different ways
But
to
you after we do
Exactly.
this, your next
categorize things.
show, you're going to develop this even further. Okay, that's going to
Yeah.
be.
I got my homework.
Yeah. Okay, good. So now, so we'll talk about like I guess we could talk about these different components of the chess game. And talk about like I guess the design of the game itself. I don't really know the history of does anyone know? I asked my son, he didn't really does anyone know who invented the game? Is it where did it come
So
from?
I'm definitely not a big historian. Uh,
Okay. Okay.
my one of my podcast guests and one of the most famous chess teachers around, actually, Sunil Weeramontree. He actually wrote a book on chess history. So I'll defer to that. But most people, I would say, say Persia. So
Okay.
like modern day Iran.
Okay.
Where it was invented.
Yes.
But, a lot of people say India, other places. So, but I'll go with Persia.
Okay. So let's say let's take the game itself and say it's an amazing game. And let's consider the different components about what kind of make it amazing, and consider these components about how, in a certain sense, they could have been different, and how that would change the game. Okay, so what do I mean? So like let's when we talk about, I guess the piece. Let's talk about how I guess the pieces. Okay, we'll talk about the pieces and the movement of the pieces, and we can talk about the rules by which govern the movement of the pieces, and those laws, the rules, can be broken down into the qualitative components of the laws and the quantitative components of the laws. What I mean by that is like, let's say you say like, I guess you could compare the way a queen moves to the way a rook moves and the way a bishop moves, and they're different qualitative. So again, the rooks only move straight, bishop moves diagonal, and the queen is both of them. So in that sense, they're qualitatively different types of movements, which each of these pieces has. But then, if you consider, for example, the king versus the queen, qualitatively they move the same. They move in all the different directions, but the difference is one of quantity. Queen moves as many spaces as he wants, but a king can only move one space. Okay, you with me? So there's distinction between like the qualitative distinct way properties of the pieces and then the quantities of those pieces. Okay.
I'm with you.
Okay. Okay, great. Now we could imagine, again, we're all familiar with the qualitative rules of the way the pieces move, but they could have been different. We can imagine a game of chess, and this is kind of the idea, these thought experiments about how would the game be if if the qualities weren't the same. Again, you have lots of pieces who move in different ways. Let's say they all move the exact same way. That would obviously make chess a much more boring game. It would be more like checkers or something like that, right? Or you could, I don't know, you could remove one of the pieces, maybe no bishops, or you can make up some new piece, which I don't know how it would move. Maybe it would move like some other shape or some other way that it would move. Or maybe you wouldn't have the law that pawns only move forward. Maybe pawns can move in any which direction. Or I don't know, you could have all different types of, maybe you could have it instead of the knights jumping over pieces, you could have the bishops are able to jump over pieces. Right? You can imagine altering the laws of the game. The qualitative laws could be different, and one could consider, well, what would the game look like if those laws would be different? Would it be interesting? Would it be as good a game? Who
Yeah,
knows?
and by the way,
Yeah,
they do. Like right now, for instance, Chess 960 has
yeah,
become
yes, that's,
popular. There was actually recently a high level tournament with, all the top players in the world. So
yeah. My son was telling me about that.
so it's yeah, it's fascinating.
Yeah. Well,
Sure.
that's actually interesting. We'll get that, but that's actually changing the initial conditions. As you remembered, we said there's like the initial conditions. That's changing the original setup of the game, right? That's not quite changing how the pieces move. I don't know. Are there any variations which change how the pieces move, or is the way the pieces move that's kind of fixed in all the different games?
Sort of. I mean, there are like, like Bug House, for instance, is a chess variant where you could like put pieces on the board. And actually Yasser Seirawan, a strong grandmaster, actually came up with I think it's called like elephant chess, where there's like actually an extra piece.
Right.
There's also plunder chess, where you capture
Right.
a piece and it can move like that. So yeah,
Right.
there's
Right.
definitely some variants.
Right.
So,
Right. Okay, so great. So again, but there's so there's a lot of different. In theory, the possibilities would be infinite, right? The possible types of laws or qualitative ways pieces would move. You can think of there being infinitely many ways, but the game of chess is unbelievable. It's such a popular game, such a great game. Part of what makes it great is the way that these pieces move. Whoever invented the game, it has such staying power that there's these particular laws and the qualitative nature of these laws is part of what makes chess the game that's so well loved, right? And besides for the again, that's the way the pieces move, but then you also have the board itself. The board itself happens to be it's square. You could imagine the board would be a triangle, or the board would be some other type of a shape, or maybe you could have even the board would be able to go from like you go on one side of the board and end up on the other side of the board like Pac-Man or something like that. You know, they could imagine the board may not even be connected. But as the particular shape or form of the board is part of what makes the game into the game of chess.
Right. So let me just bring it over to physics. So in physics, you have an electron. Electron has a negative charge. Quarks have fractional charges. Those are electric charges. There's other types of qualitative properties, and there's rules for how an electron goes from a place to place, how it interacts with light and photons. So there's these qualitative rules called quantum mechanics based upon the properties of every particle. And those rules of quantum mechanics are what's responsible and allows atoms and molecules to function in order to have chemistry. All comes from these rules of quantum mechanics. And in a similar way, the rules, space and time, how interactions are always local. That's like the whole point of space-time in a certain sense, is to create this framework, the space in which particles can interact with each other. And you don't have something, just like in the chessboard, it's contiguous. It's very important. Every space, B3 has to be connected to B2. Like these spaces have to be next to each other. If B3 could connect to E7, if they could interact with each other directly, the whole board gets screwed up if pieces aren't, the space isn't contiguous. So the same thing in physics, there's this framework of space and time governed by special relativity. It's this background which allows a logical, coherent interaction of all physical particles. And these two things, this space and time and the qualitative nature of how these particles move, if you didn't have them, you don't get a universe with all the wonderful and amazing things that we see in the universe. That's the sense we say that physics is designed, where you need certain qualitative rules, and if you can imagine different types of rules, and again, there's an infinite number of possibilities you can come up with. You don't get interesting high ordered structures. Stars and galaxies and planets and all these things are all dependent upon gravity and quantum mechanics, all functioning according to the design of nature. That's the qualitative aspect of physics.
Right. Now you could talk if we go back to chess and we talk about besides for the qualitative laws, there's also the quantities, the rules is how much the pieces move. So we could have a pawn only moves one piece, but two at the beginning. You could imagine a game of chess where a pawn moves 6 spots. It would never be able to move, or it could have a bishop was only able to move 2 spots, or maybe the knight instead of moving 1 and 2, maybe it can move 2 and 3. You can imagine playing around with the quantities of the movement of the pieces, and that would totally change the game. The game is very much the quantities of how much each piece moves is a part of what makes the game. And part of if you change those quantities, who knows what the game would look like? Arguably, it wouldn't have been as good a game. Right. So also the size of the board and the board also. How big you can imagine a chessboard is an 8 by 8. It could be a million by a million. That would be a kind of a hard game to play. Right. Or you imagine it was 4 by 4. It would also undermine the game. So there's part of the wisdom of the game is not only the qualitative rules, but the quantities of those rules. And if those quantities were to change, then that would totally throw off the game and it would make it into something arguably less entertaining.
Right. Now, physics is the same thing. These, just like, there's these pieces, analog of chess pieces is, let's say, an electron, a fundamental particle. It has properties like its mass and its charge, and there's specific numbers, there's specific quantities. And it comes out that, mass would be how heavy an electron is, or the charge would be how much two electrons repel each other. Right, the qualitative rule would be two electrons repel each other, but then there's something called the fine structure constant, which is a quantity that determines how strongly do they repel each other. And if those quantities were different, then you wouldn't have atoms, you wouldn't have stable atoms if the fine structure constant was different. Or if the mass of an electron was also different, you wouldn't have any molecules or atoms, because protons and electrons would combine to make neutrons. There wouldn't be any atoms or molecules or life or planets, things like that. So we call that the fine tuning of the constants of nature, especially in quantum mechanics, is these particles have these specific quantities that are exactly the right number, where you don't get anything interesting. Just like in chess, if every pawn can only move seven pieces, 7 pieces at a time, you're not gonna be able to play a chess game. It's not gonna work. It could literally break the game. Or if bishop only move, Ellie's came was bishop can only move 2 spaces at a time. It just takes away a lot of the strategy. You're not gonna be able to put a bishop at one side of the board and it could command the whole center. It's gonna command 2 spots. So it wouldn't take away a lot of the strategy of the game and complexity if you messed around with the quantities. And a similar thing with this space of the universe. There's a constant called the cosmological constant, which is one of the most amazing examples of fine-tuning. It was discovered in 1998. That controls the expansion of the universe. So, I guess if you imagine, it's a little bit of a strange analogy, but if you imagine, a chessboard that's expanding, where you're adding chess pieces, so if you add too many spots, the space between pieces would become less and less over time, and they wouldn't interact with each other. Likewise, you could have it contracting and things could collapse, destroy the entire game. Obviously, if the board starts shrinking, you lose enough pieces, you can't even fit the pieces on it. So these quantities that, the fine structure, the cosmological constant in physics is fine-tuned to like almost 120 decimal points, like this incredible fine-tune. Like in chess, you could add, a few more spaces on the board, you'll roughly get a chess, you get a chess game. It might not be as good as the classic chess game, but you'll get a chess game. Over here, you add, an extra couple zeros, one way or the other, from 120 decimal places. It's an incredibly small number. What's interesting, 120 decimal places and, and even 80 decimal places doesn't make a difference. It seems like it shouldn't, but it does. Even a few really makes a difference. And that's what we mean by the fine tuning of the of the space, the constant that regulates space in physics, and also the fine tuning of the quantum mechanics of the properties of particles in physics.
Okay, I just want to simplify or summarize is that then this is talking about and describing discovery of the last few decades, is that there are these numbers, and again in chess it's removing 5 squares or whatever it is. Here the numbers are like this. One of these constants is 1 over 137.139999137. On these crazy numbers, and it was discovered that if these numbers were off by a small percentage, our universe would have no structure, have no stars, no galaxies, no atoms, no molecules, no life, no planets. It would just be a bunch of electrons and fundamental particles banging around. This is a discovery. Is like, again, just like if you throw off the rules of chess a little bit, the qualities or the quantities, if you throw off the laws of physics, just in small ways, you wouldn't have a universe that would look anything like ours. It would just be total chaos with no structures of any type forming. This is discoveries recent discoveries which are indicating something special about the qualitative and quantitative components of our universe.
Right, and this is
And
also something
yeah,
that scientists agree to. This is something physicists talk about. Maybe we'll talk about multiverse in a second, but like all multiverse scientists, which is becoming mainstream, they all talk about how physics is fine-tuned. It's not something that's really, there's a large scientific consensus about the fact that the universe is fine-tuned. The question is, what does that mean? What are the implications of that? How do you interpret that? But what we've told you so far is largely a scientific consensus about fine-tuning and design, just not the interpretation of it.
right. And just the last component of the game of chess, and then like analogously, the universe is again the initial conditions, which is the initial setup of the chessboard, and that's like you were saying, it's 960 or Fisher's random, it's called, right? That's
I mean, there's a million names, but yes.
yeah, okay, yeah. So basically, the idea is again, there's a classical way the game starts, but then you could talk about 960, or there's 960 different ways that you could start. But that's only assuming that all the pawns are where they are, and you're just moving around the pieces in the in the back. But you can imagine the pieces starting at any which way. Who knows, right? You could just imagine popping the pieces down on the board and then you ran configuration. I mean, I don't think that would be an interesting game. And who knows? You tell me. With that, I mean, there's something simple about the fact that in 960, at least you have your pawn starting the same way. Imagine something totally chaotic. I don't know. Would that be a game? Who even knows? What would you say? Would you imagine the game? Are there any games like that?
Yeah, I
Start the
mean,
pieces.
look, I do think it would be very interesting. One thing I look, I am a believer of is, there's enough variance in chess, itself. So,
Right.
there's not that much of a need, in my opinion, for, others. I mean, look, at the elite level, where opening preparation is, like such a big element,
Right.
like to the point where, like games are like, mostly draws,
Right.
short, but frankly, I'm not there, so
Right.
so yeah, I
Do you
do.
like the regular classic game of chess the best? Do you think it's the best version of it? The original
Pretty
classic?
much. I mean, I'm not that much of a classical player anymore. I feel like I retired. And I mean, I'm kidding, but like I still play classical tournaments, but I do probably prefer like speed chess more. But no, I'm not a. I mean, look, I've played Crazy House. I played other like chess variants, but mostly for fun once in a while. But um,
Right.
yeah, there's a lot to learn in chess itself.
Right, I can
Right.
see
Uh,
that. Um, yeah, so just in terms of the universe, it's the same thing. The way the universe started off, it's incredibly important. And if the universe just, it's called entropy. It's the arrangement of the way the original arrangement of the universe. It's a little different. It's a little more abstract. And the analogy would be in chess is arranging the pieces differently. It turns out in physics, it's actually the way the board is arranged. It's actually the low entropy comes from the shape of the board. We haven't really discussed gravity, but gravity would be right. You're in chess, you play with a flat board. There's no curvature in the board itself. So in the universe, it's there's general relativity, which deals with the shape of the universe, and it turns out that the low entropy, the really unusual state arrangement of the universe, comes from that aspect. But in any event, it's just the initial arrangement is incredibly unlikely value if it was just chosen by pure chance. This was calculated by physicist Roger Penrose in the 1980s. It's 1 out of 10 to the 10 to the 123rd. It's a staggering number. It's a double exponent where the exponent 10 is raised to the exponent of 10 to the 123rd. It's this astonishing number. And it's incredibly low entropy, which is really high order. And it was selected in a certain sense, or a random. That's the very question we'll discuss in a second. But that's the initial arrangement. And if had been in its most likely state, whatever the most likely state of the universe to start off in, essentially be filled with black holes. Black holes are the most likely arrangement of matter, where it's the highest entropy. The most probable state would be all black holes. And the fact that we don't have a universe filled with black holes is because the initial configuration of the universe at the Big Bang was very improbable and a very specific arrangement.
Right. So I guess putting these things together, if you look at the game of chess and you wanted to admire it and then say, I wonder how this game came about. Did it just come about by some random, I don't know, some kid just writing down a bunch of things on a paper and saying, oh, let's make a piece that moves diagonal. Let's make a piece that, let's make a board that's 8 by 8 and whatever. It's arguably that you're not going to get the complexity, the amazing game of chess without it being designed by some sort of genius or at least who had this idea, and there's a lot of thought that must have gone into it based upon again, the different components of the game. You have the qualitative nature of how the pieces move, and the quantities of how they move, and the way the board is, and the initial arrangement of it. All these different components of the game itself indicate that they were designed by someone or some group of people who thought it through, or maybe, again, it may have evolved over time. But again, it was designed by people who understood the wisdom of the strategy which go into the game itself. And because of the fact that you see all these different components come together to be able to yield this amazing game. And that's, again, this is in the small, compared to the universe as a whole, this is just in the game of chess. But it demonstrates a designer, someone who fine-tuned the quantities to be just right and set up the initial setup to be just right.
Right. You don't believe it. There's no reason to think. It's just that every single arrangement of pieces was tried out once and pawns were scattered around the board. It is, there was somebody intelligent who realized there has to be a symmetry in the board. You want to make the black and white have to be evenly balanced. It was specifically designed in order to facilitate a competitive game, which allows for strategy. You don't want to start it off where there's already in checkmate. There's like obvious things that the game of chess was designed and fine-tuned, and it wouldn't make anybody, right away that you want pawns to move one piece, not seven pieces, seven spaces at a time. It was clearly done by intelligent people who, they might have tried trial and error to some degree, but if somebody were to tell you that no, there was billions of versions of chess that were tried out thousands of years ago, and there was all randomly arranged pieces with different rules, and happens to be one of them survived, that was the best one, and that's how we got our game, you would say, come on, that's ridiculous. That's not the way it is. It was clearly made by intelligent people who thought through what are good principles to have in order to achieve a competitive, interesting game filled with strategy and complexity. And yeah, they might have tinkered around with it, but it wasn't trying out, billions and billions of variants of stupid variants that don't work out and are non-competitive until they finally settled on it. And in a similar way, that's kind of the question of how to interpret the one universe we see. We see one universe with fine-tuned constants of nature, with design qualitative laws, and with incredibly organized initial conditions. And the question is, how do you interpret that? Do you say there's an intelligent cause that selected the initial conditions so that we wouldn't have a universe with all black holes? We get a universe with galaxies and stars and planets. Do you have something intelligent which selected these laws of nature for the purpose of having stable atoms? And did it set these constants to these precise numbers? Because if there were any other values, then you're not going to get planets and stars and atoms and molecules. So we're saying there's one universe, and if you look around, it's ordered and it's designed and fine-tuned, and that indicates that the cause of the universe and the cause of the laws of the universe is intelligent. Just like, and you wouldn't say that there's an infinite number of other universes. That's what scientists say. Go ahead, Ellie, tell them about what they...
Yeah, the other way to explain the unbelievable design, fine-tuning order of our universe is the other explanation out there is to say that there really are infinitely many universes out there. They all exist, again, parallel universes, like nowadays is popular in science fiction and movies and Spider-Man or whatever, but this is a current scientific thinking. Many scientists, again, there's no way to prove this. It's just they say there are infinitely many universes out there, and in every universe, these numbers, these constants are a little bit different, and the laws are different, and the initial arrangement is different. And by chance, obviously, if you have infinitely many universes, you're going to happen to have one of them that just works out perfectly right.
Wow.
And obviously, if we're here, we're going to be on that one universe. So that's it, and that's our explanation. So again, it'd be like, but again, there's no way to have any evidence for such a thing. It's just it's a theory of, again, positing, instead of recognizing the order and design and fine-tuning of our one universe, it's explaining it away by positing infinitely many unobservable parallel universes, and it would be analogous to saying, you see this one unbelievable game of chess. Instead of saying this game was designed by brilliant game designers, you say, you know what, there's infinitely many games out there and none of them survived, and this is the one game that just happened to survive because it was the only one which is good. That would be a ridiculous way to explain the emergence of the game of chess. So in that sense, you're saying is the laws, the modern physics, the study of modern physics leads us towards the conclusion that that there's a God who designed, to or fine-tuned, to set up the conditions of our universe to unfold into our amazing universe. And over time, but again, That's why it's saying people, atheists or a lot of scientists will tell you nowadays, God is an outdated idea. But on the contrary, the discoveries of modern physics point directly towards the fact that there's an intelligent cause of our universe.